Assalamu alaikum. My name is Hamza Rahman and I'm currently doing my bachelor's in mechatronics engineering from Air University. So today we are going to discuss how a computer works and the flowcharts algorithms. So let's start. Computer Computer is an electronic device it processes data and performs tasks based on instructions provided. The categories of computer are mainframe computers, mid-sized computers, and microcomputers. Then comes the computer system. A computer system is a combination of hardware and software that works together to perform tasks. The elements of computer system are hardware, software, CPU, the central processing unit, the main memory, secondary storage, input/output devices. Central processing unit CPU. This is a part of a computer that consists of CU, that means control unit. It fetches and decodes instructions. It controls flow of information in and out of the main memory, and it controls operations of internal CPU components. Then comes PC, that means program counter. It points to next instruction to be executed. Then comes IR, instruction register. It holds instructions currently being executed. Then comes ALU, arithmetic logic unit, performs all arithmetic and logical operations. Here comes the figure. The diagram shows the hardware components of a computer. You can take and look at this figure for more information and understanding. Now we are going to discuss the parts of the memory. First comes the primary memory, and it is a part of the main memory. It consists of or it performs the function like directly attached to the CPU. Program must be loaded into the main memory before they can be executed. In primary memory comes RAM, random access memory, and ROM, read-only memory. Random access memory or RAM is volatile. That means it is temporary storage or temporary memory, and ROM is non-volatile. That means it is permanent storage. It is used for permanent storage. Then comes the next type of memory, that is secondary memory, and its function or its uses etc. You can call it anything, that are not directly attached to the CPU, that is central processing unit. Devices stores data permanently. In secondary memory, the device stores the data permanently and it is non-volatile, and unlike RAM, it performs the same function as ROM. Examples of secondary memory are hard disks, flash drives, floppy disk, zip disk, CD-ROMs, tapes, DVDs, USBs. Currently in 2025, hard disk is used, flash drives are not used, floppy disk and zip disks are also not used. CD-ROMs are used but not frequently. Tapes are also not used, DVDs, etc. They are also not used. Then the part of computer that plays a vital role in the function of a computer are the input and output devices. Input devices are used to transmit data to the computer or system. Like input devices can be mouse, scanner, keyboard, or you can use many other type of input devices. That's up to you. And output devices are the devices that display results. The input devices or the data you input in the computer are then displayed on the output devices, and CPU is just converting the data. And output devices consist of monitor, printer, speaker, etc. Then comes the software. Software is a set of instructions that aid computer to perform tasks. Software can be categorized into two main types. The number one is system software. System software manages the computer like 10, Windows 10. Application software for specific tasks like MS Word. System software manages the computer, and it is a vast type of software, and application software are just simple apps that are present in the computer that we use for various purposes. Software is vital in modern technology. You know that software is very important in nowadays, driving everything from smartphones to computer. It is a function of software. Then comes the computer languages through which we create softwares, and the language that computer or machines understand. Computer only understands digital signals, zeros and ones, that are binary digits, binary code or bytes, etc. Language consisting of binary commands directly understood by CPU. As I said, binary digits, the digit 0 and 1, binary code, the sequence of zeros and ones, and byte, uh, 8 bits are equal to 1 byte. Here in this table you can see the conversion of byte into bits and bits into bytes, vice versa. Evolution of programming languages. In early ages, the computer were programmed in machine languages. The machine language is very difficult for human to write and to understand and to read, etc. For example, to calculate area of the rectangle, length into width in machine code, the following is the code you can see. As you can see, it was very difficult. Then comes assembly language, that is closer to humans as compared to machine languages. Instruction are mnemonics, English-like words, assembler, the tool that converts assembly code into machine code. As the time passes, the machine languages that we used for coding in early ages was further converted to assembly language that was more feasible for humans to read and write, and humans could understand and learn this language more precisely and easily. So it was very easy for humans, not as much easy, but as compared to the other language, that is machine language, it was easy. And we used a tool that is known as assembler, that converts the assembly code or the assembly language into machine language or machine readable code or machine readable language. Here is an example of assembly language. As you can see, assembly language code to calculate the area of rectangle. Area of rectangle is length into width. Uh, in this language, human-like words like load, mult, stur were used for 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 length, width, and area. As the time passed, the machine language was converted to assembly language, and then it was further converted to high level language, or that we use nowadays in our current life. The softwares, the computers, many other applications are coded or made with these languages, and these are very easy uh, as compared to assembly language and machine language, and it is very easy to code with them. Now we are going to discuss the high level languages. Language that are easily understood by humans. High level language are C, C++, Python, and etc. Compiler. The compiler is a tool that converts high level language into machine readable language. Compiler 2 translates source code into object code. The equation for area is equals to length into width can be written in C++ as area is equals to length into width. As you can see, it is very easy for humans to calculate the area using C++ in high level languages. C++ programming. C++ was divided by, I cannot pronounce this name correctly, in Bell Lab 1979. Initial name C with classes. In 1985, C++ was first appeared to the world. C++ is a high-level language. C++ is machine independent. Compiler is needed to compile the C++ programs. Now we are going to discuss the algorithms and the flowcharts. Algorithms and flowcharts. A typical programming task can be divided into two phases: problem solving phase and implementation phase. Problem solving phase produces an ordered sequence of steps that describe solution of the problem. This sequence of steps is called an algorithm. Implementation phase implements the program in some programming language. Steps in problem solving. First, produce a general algorithm. One can use pseudocode that refine the algorithm successively to get step-by-step detailed algorithm that is very close to a computer language. Pseudocode is an artificial and informal language that helps programmers develop algorithms. Pseudocode is very similar to everyday English. So these are the steps in problem solving. If a code is given to you or a question is given to you, uh, like create an algorithm or write an algorithm and make a flow chart, etc. We are going to discuss the example uh, in further. Pseudocode and algorithm. Here is an example that says write an algorithm to determine a student's final grade and indicate whether it is passing or failing. The final grade is calculated as the average of 4 marks. So you can see this is the pseudocode that is very similar to normal English language, and it makes our work a lot easier. So the question, you have read the question, and it is the pseudocode like input a set of 4 marks, calculate their average by summing and dividing by 4. If average is below 50, print fail, else print pass. Here if else function was used. Now this is the algorithm, the step-by-step procedure. Step 1 is input M1, M2, M3, M4, the marks of the student. Step 2 is the grade, that is the average that can be calculated by summing all the marks and dividing it by 4. Step 3 is if the grade is less than 50, then print fail, else print pass. And at the end if function is used. So this is the detailed algorithm. Now comes the flow chart. Before discussing and seeing the flow chart of the above example, we are going to see what a flow chart is. A flow chart is a schematic representation of a sequence of operations as in a manufacturing process or computer program. This is the dictionary that the dictionary says the meaning of the flowchart, and a graphical representation of the sequence of operations in an information system or program. Information system flowcharts show how data flows from source documents through the computer to final distribution to users. Program flowcharts show the sequence of instruction in a single program or subroutine. Different symbols are used to draw each type of flowchart. A flowchart. A flowchart shows logic of an algorithm, emphasizes individual steps and their interconnections. Example: control flow from one action to the next. Now comes the flowchart symbols. This is a very important slide as in this slide the symbol, the name and the use of the flowchart is shown. As you can see, the oval symbol is used to denote the beginning and end of the program. Just like you can write start in the oval and end at the end, you can write END, end, in the oval symbol. Then comes the parallelogram. It denotes an input operation. The example we discussed earlier, I'll show the flowchart of that example. Then these symbols will get more clear, and the function of the symbols will get more clear to you. The rectangle denotes a process to be carried out, example addition, subtraction, division, and you can calculate the average, etc. The diamond or the rhombus denotes a decision or branch to be made. The program should continue along one of the two routes. In the diamond function or symbol, the functions that are used are if, then, else function, etc. Then comes the hybrid. It denotes an output operation. And then comes the flow line. It denotes the direction of the logic flow in the program. It is the flowchart. The previous example we have discussed the pseudocode and the algorithm, the detailed algorithm of that example, and now this is the flowchart. You can see the detailed algorithm is given here, and this is the flowchart. Now the previous slide functions, the shapes, you can see the shapes and By seeing this flow chart, the previous shapes would get clear to you. Here's the oval that starts the function. Then in the parallelogram comes the input of the marks, and you can see the arrow that denotes the direction of the logic flow in the program. And then comes the grade in the rectangle, and there is the diamond that I have said that uses the function of then, if and else, etc. And then this shape hybrid that executes the print function. Then comes the oval, again oval for stopping the function. Here is another example for writing an algorithm to draw a flow chart to convert the length in feet to centimeter. First, the first step is writing a pseudocode that is very similar to the English language, and it makes our work a lot easier. So the pseudocode is input the length in feet, calculate the length in centimeters by multiplying length into feet with 30. Print length in centimeters. As you know, in basic conversion, 1 feet is equals to 30 centimeters. So you can convert the length into feet by multiplying it with 30. Here you can see the detailed algorithm and the flow chart of that example. In the algorithm, we see the step 1 is the input that the user input the length that is in the feet that is going to be converted into the length that is in centimeters. So step 2 is multiplying the length into feet and the length that is in feet by 30. The step 3 is print LCM, that means printing the length that is in centimeters. Here you can see the oval that begins the function, that starts the function, parallelogram that is used for the input, and the rectangle that is used for the conversion, and the hybrid. In this example, the diamond or the rhombus is not used, as in this example the function like if, else, and then was not used. So directly from the rectangle we have gone to the hybrid shape and then to the stop function. Flowcharts. Flowchart is a graph used to depict or show a step-by-step solution using symbols which represent a task. The symbol used consists of geometrical shapes that are connected by flow lines. It is an alternative of pseudocoding, whereas a pseudocode description is verbal, a flowchart is graphical in nature. As you have shown in the previous examples that we discussed, here are some other flowchart symbols. The new ones are this printer output symbol shows hard copy printer output. The disk storage input output symbol indicates input from or output to disk storage. This we have discussed. This we have also discussed. So that's it, guys. Thank you for watching, and soon we'll make another video about the further lectures and the further concepts and Allah Hafiz.